Hey there, in this video we're going to work on solving rational inequalities. So rational inequality is something that looks like this. You have p of x over q of x, and then you have either one of the inequalities that looks greater than, less than, greater than equal to, or less than or equal to something else. Usually 0. If it's not equal to 0 on one side, you got to make sure it's equal to 0 on the one side. And then we're going to have it. First step is to factor completely, just as we did with polynomial inequalities. Factor completely. The second step is to find the zeros and plot them on the number line. And then use test points to test the regions, to check the regions. Use test points for each region. So a rational expression, it's a quotient, so we're going to be checking the quotient in this case, and then the last step is write in interval notation. So let's go ahead and factor completely first. So I want two numbers to multiply to 1 and add up to -2, since this is a quadratic. So that looks like it's x minus 1 times itself, so it's x minus 1 squared. Or, and now here I want two numbers to multiply to +2 and add up to 3. So that will be x plus 1 and x plus 2. Greater than or equal to 0. And so how do I solve this? Well, now we find the zeros of each factor and plot them on a number line. So let's see. So what makes x minus 1 0 is when x is 1. So we're going to plot 1. And now these ones they make the rational expression undefined. So any zeros from the denominator make the rational expression undefined. From the denominator, make the whole thing undefined. So usually, personally, what I do is I usually put, and let me, because I'm going to get -1 and -2, let me remove this 1 over here. So I'm going to put 1 over here, and then -1 and -2. So because at 1, the 0 is x equals 1 in the numerator, and I can't equal 0, then I'm going to put a 0 there. So that's my personal preference. And these, because these come from the denominator, I usually put a u above it to remind myself that these are undefined. And so when I put circles on them, and the reason that I do the 0 and the u is because it helped me say, like, okay, so which ones do I include? Well, I'm definitely going to include that one because it can be 0. Now those, the denominator is 0, but that makes the denominator being 0 makes the whole expression undefined. So I actually don't want to include those because I don't want to make the rational expression undefined. So those circles are going to stay open. And now, because I have 3 numbers on my number line, I have 4 regions to test. So I'm going to pick my test points. And what I'm checking is the quotient. So x minus 1 squared over x plus 1, x minus 1. Oops, x plus 2. And so what do we want? We want things that are greater than or equal to 0. So greater than or equal to 0 means we're looking for the quotient to be positive. So we want a positive quotient. So let's pick our test point. So in the first region, I have -infinity to -2. So in -infinity to -2, parentheses, because I don't want to include that, let x be -3 and put it into the quotient. So I'm going to have -3 minus 1 squared over -3 plus 1 and -3 plus 2. So the numerator is -4 squared. So it's going to be a positive 16. Again, we don't necessarily care too much about the quantity, but the sign. So that's positive in the numerator. In the denominator, again, -3 plus 1, that's -2. But most importantly, is negative. and negative 3 plus 2 is a negative 1, so it's negative. So I have positive divided by negative times a negative is a positive, so I get positive. So this is the representative that we chose was negative 3, and that gave us a positive, which is what we want. So we are going to shade that. So we shade here. And now we pick a representative between negative 2 and negative 1. So what could I use in there? So in negative 2, negative 1, notice I'm using parentheses because neither of those are included. And again, the reason that I'm not including those is because those came from the denominator, so they actually make the rational expression undefined. So in that, let's let x be negative 1.5 and plug it in. So I'm going to have negative 1.5 minus 1 squared over negative 1.5 plus 1 and negative 1.5 plus 2. So I noticed that the numerator, it doesn't really matter what we put in here because when you square it, that's going to become positive. So the numerator, the denominator, negative 1.5 plus 1, I'm left with a negative 0.5, so it's negative, and negative 1.5 plus 2 gives us a positive. So I'm left with a positive over negative, which is negative. So we don't want that, right? We're looking for things that are positive. And let's move on to the next interval. So I have in negative 1 to 1. So notice negative 1 is not included, so parentheses, but now 1 is included. 1 is the factor that came from the numerator, and so what makes that 0 is 1, since it can equal, since I have that equals there, so that's going to be a bracket. Let x equal 0. Anytime you go from a negative to a positive, be nice to yourself and let x, choose x equal to 0. I'm going to give myself some more room over here. Pick x equal to 0, and so you're going to have 0 minus 1 squared over 0 plus 1 and 0 plus 2. That everything here is positive. And so you get positive. So do we want that? Yes. We are looking for the quotient to be positive, greater than 0. And then the last region is 1 to infinity. So in including 1 to infinity, what can we pick? Let x be 2 works, and all you need is a representative in there, so it doesn't matter what you pick as long as it comes from that region. So when x is 2, I'm going to have 2 minus 1 squared over 2 plus 1 and 2 plus 2. And again, everything is positive, so I get positive. So do I want that? Yes. So that we will shade it. Another way that you can think of it is, based on the power of the factor. And when we were graphing these, remember there was a point that we talked about is when you hit a 0, is it going to go through or is it going to bounce off? And so that comes from the power. So as you hit a 0, right, in this case, because this is square, you're going to bounce off. So that means that the sign is not going to change. So looking at the regions, you can look at the factors also based on the power. So one quick way to do it is noticing that if the power is even, then your sign is going to stay the same. If the power is odd, then the sign is going to change. So starting with my x equals negative 3, right, I can still do my test point and notice that I get a positive. Now, using my little trick about the power, as I go across negative 2, I'm going to ask myself, which factor gave me negative 2? Well, negative 2 came from x plus 2 to the first power. So since the power is odd, my sign is going to change. So I had positive, so it changes to negative. And now I don't have to do test points anymore because I can say, okay, now I have a negative. As I go across negative 1, where did negative 1 come from? Which factor? Negative 1 came from x plus 1 to the first, which is odd as well. So the sign is going to change. So I had a negative, it's going to change to a positive. And now as I go from positive, I go across 1, where did positive 1 come from? This 0, positive 1 came from x minus 1 to the second power. Since this is even, then my sign is going to stay the same. So I had a positive, it stays positive. So that's a bit of a shortcut to, you still have to do a test point in a region, but then just go by the factors. Is it an odd power or is it an even power? As you go across a factor, right, at a zero, sorry, -2, where did -2 come from? Came from this factor with an odd power, so the sign's going to change. So you go across 1 here, where did 1 come from? Positive 1 came from the x minus 1 factor, which is to an even power, so the sign will stay the same, so it doesn't change. So now, how do we write our answer with that number line? So we were looking for things that are the quotient to be greater than or equal to 0, which means positive. So all the pluses. So that one, and that one. So we can go and write our interval notation. So the solution will be x is in the interval, and we have negative infinity to -2, parentheses because we're not including it, union, and then -1 to 1. But notice that this one, the whole thing stays positive. So we can just include, since the 1 is included, we can just go all the way from -1 to infinity. But I'm gonna I am gonna break it up just so you see what I mean. So we're gonna go from -1 not included to 1 included, and then we will say union 1 to infinity. But this doesn't really make sense. If we're including 1, then we can just combine the intervals. So combine them. So my actual solution then would be -infinity to -2, not included, union, not including -1, all the way to infinity, since it doesn't make sense to separate them since 1 is included. And that will be our solution. So anytime solving rational or polynomial inequalities, factor completely, find the zeros of the numerator and the denominator and plot them on a number line. And anything that comes from the denominator will not be included, regardless of whether that is equals or not, because anything that comes from the denominator makes the actual rational expression undefined. And then use test points for each region, or you can use the power trick that I just described to you, and then write an interval notation. Okay, email me if you have any questions or see me in office hours.